Sometimes you'll encounter slow wireless transfer speeds, and it could be that you just need to upgrade the wireless adapter on the laptop or the PC. And you might be running something like 802.11g. You may want to consider upgrading to 802.11n or 802.11ac. Just make sure that it's going to be compatible with whatever wireless access point you're connecting to. So if you upgrade your wireless adapter on your laptop or your PC to 802.11ac, you want to be sure that the wireless access point is accepting 802.11ac 5 gigahertz signals. Slow wireless data transfer rates can also be caused by interference. And we talked about the interference. It could be almost anything electronic, especially if that device is working within the same frequency range as your wireless adapter or your wireless access point. So smartphones, tablets, laptops, PCs, other wireless access points, a neighboring company's wireless access points, and any other electronic or electrical devices that work on the 2.4 or 5 gigahertz spectrums. It could be a microwave. It could be HVAC equipment. It could be anything like that. So you want to watch for that RFI, that radio frequency interference. And one of the things to consider is how you're connecting. For example, with 802.11n, you could connect via 2.4 gigahertz or 5 gigahertz. And if you remember, our Soho router that we showed can transmit on both of those frequencies at the same time as two separate wireless networks. What I usually do is I put a 2.4 on the end of the SSID name for the wireless network that is transmitting at 802.11n at 2.4 gigahertz. So that's something to keep in mind also. If you have a lot of other devices on the 2.4 gigahertz frequency, and that's very common, then you might want to change it over and just have your wireless access point broadcast on 5 gigahertz for 802.11n. And, try to stay away from 802.11g and especially B. With 802.11ac, you don't have to really worry about that because that's a 5 gigahertz frequency only. So another thing to watch for is interference of different types, and then which type of 802.11n network you're connecting to. Then there's also the distance. The farther away you are from the wireless access point, the slower your data transfer is going to be. That's it, because the radio signals have to pass around or through walls and doors and ceilings and floors and everything else. So the distance is really going to be the big factor. I usually like to keep computers and mobile devices on a LAN indoors. If they're indoors, I like to keep them within 100 feet of the wireless access point. Once you go beyond 100 feet, even with 802.11n and AC, you can get a lot of problems. So watch out for that distance. Now, outdoors, you can usually double the distance, but you still do have to watch for how far you go and the interference as well. And then finally, throttling and capping. It's basically the same thing. It's kind of like your internet service provider can cap your rate, your data transfer rate. So you might have an internet connection that could possibly go as fast as 200 megabits per second, but the potential is there, but they're not going to give you that because there's so many people sharing that network. So they're probably going to cap you at something like 30 megabits per second, or you can pay more to get 50 megabits per second. So this is throttling the network transfer. Sometimes it might be throttled up and down at various times during the day. It might be throttled down during lunch and at, say, 4 o'clock in the afternoon when people are getting all their work done before they leave. So throttling is actually slightly different than capping, but both are possible on a wireless access point. A network administrator might want you to only have a connectivity of 100 megabits per second, even though your connection could go as fast as 300 or 600 or even 1 gigabit per second. Here's one of our Soho routers, and this one actually does provide for capping for guests, and they call it bandwidth control. And so if we go to the guest network here, you'll see we have access and bandwidth control, and you can allow guests access to the local network and enable the bandwidth control for those guests. And you can have that at 256 kilobits per second or more, and you have basically your ingress, that's inbound communications, and egress, that's outbound. So if the person on the LAN is trying to go to a website, they'll download information at 1024 kilobits per second, and they'll upload their emails at, say, 256 kilobits per second. So ingress and egress. That's bandwidth control. So that's one example of that. If you're a guest on a wireless access point, that could be one of the reasons why you have a lower connection, a lower data transfer rate than you would normally expect. So throttling and capping, distance, and interference, got to watch for all those when you're troubleshooting slow transfer speeds. And let's take a look at our AV editor. And here we are. Now we can take a look at our wireless access point by going down here to the Start button, right-click on that, and go to Network Connections. This is Windows 8.1, by the way. And we'll right-click on our Wi-Fi connection and go to Status. This is where you can go to quickly find a lot of information about your connection. Now you can see the signal quality here, full bars, full 5 bars. So we're good with that. And it should be, because it's an 802.11 AC connection, and it's about 8 feet from the Soho router with wireless access point. So it should have good connectivity. The speed is at 288 megabits per second. So we're pretty much maxing out at 300 megabits per second for this connection. And this is indeed an 802.11 AC connection. So, you might see this speed also for 802.11n connections. You might see faster speeds than this for 802.11 AC. But when you start to, if you have an N or an AC connection and you start to see speeds of, say, 50 megabits per second or 20 megabits per second in comparison, you'll probably also see that the signal quality has degraded. The two usually go hand in hand. It might not be, but generally that's the case. So you want to check all those things that I mentioned and look in here at the Wi-Fi status and see exactly how your connectivity is doing. You can also get here by bringing up the taskbar here, and you'll see the wireless network here. We can click on that, and that'll bring up your wireless connections here. You could also right-click on that and go to Open Network and Sharing Center. And from here, you could go to your Wi-Fi connections or change your adapter settings, which is where we went from the Start button. I like the Start button for that reason. It works pretty well. You have lots of features here when you right-click the Start button in Windows 8.1. A lot of the ones that I use very often. And so I like how this is designed by default. You can modify this with third-party applications if you want, and modify this within Windows to show more items. But I like the defaults here: the Run prompt, Control Panel, Task Manager, Command Prompt as admin, Computer Management, and that Network Connections, because you're going to go there a lot for your network connectivity to check the status of a connection, to enable or disable that Wi-Fi connection, and then to go to Properties and check the IP version 4 or IP version 6 configuration. So that's a nice little setup there in Windows 8.1. And so remember how to get to the status window for the exam and for the field for your Wi-Fi connections and for your LAN connections, because you can troubleshoot from here as well. And if you do have a problem with your speed, you can try to diagnose it and use the built-in troubleshooting tool within the control panel. You may have some luck with that, you may not. But if you remember all of the things that we talked about with network troubleshooting within this course, you should be able to fix these problems and fix anything that is caused by distance or interference or the wrong network type or a problem with the wireless access point or this wireless adapter.